The development of this project allowed us to apply in a practical way the knowledge acquired in the field of logic automation. The objective of this work is to find a daily use for the topic seen in class and based on the needs of each person. We get enough information to carry out a personalized automatic irrigation system.
The explanation of the system is pretty much that we needed a sprinkle to do a different quantity of time watering the plants. This we made by using D-type flip-flops, as shown here, and a digital counter, which pretty much will make us select the time we want it for it to make a cycle. So we're gonna make, in this example, cycles each 20 seconds. And every time a cycle finishes with those 20 seconds, one of the flip-flops is gonna get activated. So as we can see here, the first one has only one connection, the sprinkle or the LED as presented here. That means it's only gonna be on for 20 seconds. Then the next sprinkler is gonna be on for 40. Why? Because we have it connected to two flip-flops, and each flip-flop has a cycle of 20 seconds. And the third sprinkler will have a time of 60 seconds. Why? Because it's connected to three flip-flops. And at the end, I'll explain how the frequency will stop. So first, what we do is we have our switch here that we have on or off. Right now it's open, so the frequency that the clock is gonna give is gonna be none, so nothing's gonna be running. But once we start with the frequency here, it's gonna make the rounds up to 20, and we have to enable it to start again from 0 or for it to stop. So here, first we need to get our sequence of 20. How we did that? In the first one, we needed a 0 as presented here. I negated it because we needed an on light. And since to have a 0, we only need the two first digits to be 0. If I negate it, it's gonna be from off to on. And that's gonna enable this AND. And this AND is also gonna get enabled by the two right here. So that's why we're gonna have it like that. And why is there an OR here? The OR is pretty much for the enable, because when we have an enable to be on the whole time, it's gonna stop. If we put enable as on and off, as I pretend to do here with this OR, because once we do our cycle of 20, this OR is gonna get on, but then it's gonna come back to 0, and then it's gonna be off again, enabling the program to run again. But if I always have it on with an OR, it's gonna stop forever. And if you see it, this OR is connected to the last flip-flop right here. So when the value of on comes to the last flip-flop of the system, it's always gonna be on, and the enable is gonna be on, and it's gonna stop. There's not gonna be more frequency right there. And then I only need one sprinkler to be on at the time. So I did that with an AND connector. I didn't find one of 6 connections, only 7. That's why I put the one here just to give it the value. But it's pretty much connected to all the negated values, so that's gonna be the first value that's gonna give here. So once everything is with a 1 as a negated value, then we're gonna start again here. But otherwise, it's always gonna be off. So the value that the flip-flop is gonna keep giving to the other flip-flop as a shift register function, it's gonna be a 0, and only 1 is gonna have the on value. But anyway, it doesn't matter because it's only gonna run once, because when we have the final value right here in the last flip-flop, as said, it's gonna go back here and it's gonna stop the enable from doing anything else. And as well here, it's gonna stop the frequency to keep going. So we have an OR here as well, one that comes from the frequency, one that comes from the enable, meaning when it changed the value, when the cycle, I mean. And when we want it to stop, we have to give the clock a steady value. It could be on or off, but it has to be a steady value. So how do I do this? When the last value of the D-type flip-flop, the last one, gets here, as we can see it in the connection, it's always going to be on. So the clock of the first flip-flop is not going to run anymore, and none of the clocks. So it's going to make the system stop. And that is how this system works. And the main reason why we want different times of each flip-flop or LED light or sprinkler, as it would be a project for a watering system, is because we pretend to be watering different types of plants at the same time. And each plant needs a different amount of water. It's not the same to water a field of grass than to water a tree or like some flowers or yeah, well, whichever different plant we could have in our garden. So this is to establish a time. As said, we can change here the cycle. It doesn't have to be 20 seconds. It could be 30. It could be 40. It could be 60. We could just change it to make it a different value. We can make 80 seconds, 90 seconds. We can even add another 74, 190 to add more seconds to have like 3 digits and increment the time that is going to be watering the plants. But this is just for the simulation. So let's watch it running. So we press it on. We see that our switch is open. But by the time we close it, see, the first light is on, watering the plants, but it's not running. Rather, sorry, my computer is a little bit slow right now, but we see 20 seconds and the second light turned on. One round to round 40 seconds already off. Then the next one is gonna give 3 rounds of 20 seconds, leaving it on. And when it finished those 3 rounds of 20 seconds, it's gonna get off. See, and the system stops, the counter stops, and the sprinkler stop. So that is how it works. Thanks a lot for the attention and have a good evening.
This course helped me to increase my logical thinking, because every problem that we solve need a lot of ingenuity. Solving problems outside is not as easy as we think. That's why I think this course was very useful, to understand how things work and also how we can implement more engineering in the objects we use daily.
As my conclusion, I could pretty much resume that I learned a lot in this course. With the final project, I could implement pretty much everything we learned during the semester, such as switch registers, and not or connectors, code converters, seven segment displays. So I think it was a project where we could sum everything up, and I really like the course. I think that, as the name of the course says, logic automatisms, it really makes you think in a logic way to make things work. It makes you analyze things in a better perspective. It makes you think out of the box and how to make things, how to make them easier, how to not complicate stuff, how to get to the same point or the same goal with an easier path. So I learned a lot, not only for applying to this course or this assignment, but to pretty much apply in any other subject or any other obstacle that I could have in life. The logical thinking I think, is one of the keys for a successful either project, either even life, if you want to call it that way. So I really enjoyed it. I think that Alejandro Aragon as a professor was great. I always feel accompanied. I always felt supported. So I really like having him as a professor. And I mean, he's a professional. He's really good at his ground. So I really liked it. And I was happy to have this course. And I think I learned a lot. As said, not only for the assignment, but for anything that I could apply logic on.